Thank you very much. Yes, I'm very happy to be here. I want to thank the organizers. And there's a microphone. Is there? Is this? This? Oh, all right. Okay, so I'm going to start again. I'm happy to be here. I'm happy that you're here. I want to thank the organizers and who put this all together. I want to thank the Qualia structure people for providing additional funding to be here. And I want to thank my collaborators. See a few here. I actually switched distances are already such a problem that I'm just going to focus on distances and let the continua fall to the wayside. I hope you forgive me. We can talk about this later. Just a short mention also that if you're interested in the topics that we're going to discuss here, there's a special issue in the journal that I'm co-running, Philosophy and the Mind Sciences, on structuralism, and the deadline is on the 1st of September. So if you want to contribute, feel free to talk to me. And we have a broad range of topics that would fit this conference. And the Models of Consciousness conference is also happening in Bamberg, where we have a whole panel on phenomenal structures and spaces, which would fit, I think, a lot of the ranges of talks that we've heard here and posters. But let me go into the talk. I want to start with a short motivation for why I'm interested in the problem. I'm going to then talk about the problem of phenomenal distance, and I'm trying to look at different solutions, arguing for the pros and cons, and then we can have a discussion of whether you see different pros and cons. So the motivation comes from old school philosophy. John Locke had this idea that two people could look at the same thing, but experience different types of qualities, right? And he's very strict in saying, well, this could never be known, right? So apparently there's this kind of motivates of the privacy of consciousness very often, that there's something in there that just is not easily translatable. And I think this, to a degree, can also be empirically motivated. This, for example, is the distribution of different types of color coding cone cells in 5 different individuals. And you can see that there are huge differences in the number, but also the type of experience that you're seeing. And for a very specific stimulus of 550 nanometers, this is the rating. You can see the person that uses just this kind of red coding cells always uses this, judges this nearly as a red color, despite it not being red, right? It could be any other, depending on where this ray would be hit. But this, so there is a way in which we can already have kind of some idea that probably for the same stimulus, we're not experiencing the same thing. But there's still a way in which we can ask, well, under which different stimuli do two individuals experience the same? And I think this is the motivation behind the kind of qualia alignment problem, if I see it correctly. So I want to talk about this because the resistance when it comes to judging the structure of consciousness has always been kind of these kind of a-structuralist view that we can trace to, for example, Clarence Aurelius, who said that, yeah, what you can do is you can designate the qualia to locate an experience, that is to designate the conditions of its reoccurrence or the relations of it, but such a location does not touch the qualia itself. Like the experience of redness is not touched by its relations. That's the challenge that Lewis is giving. And you can find the same in today when Joe Levine writes that talking about, the specific type of red experience that he has with this cassette case. It's a little bit of a, aged example, but the point is that you don't show that a property is itself relational by finding a relational description that uniquely identifies it. So even if we say that there are all these relations, and we know that only one thing can fit into this location in that relation, it does not show that it is relational. So it might still be that the property is itself intrinsic. It just turns out that only it satisfies the relevant description. So this is the trouble in the background. If that is the case, then you can switch qualia around and you get the kind of inverted spectrum or kind of shifted spectrum problems. So it's a little bit like a question of character. What gives a conscious event this type of specific phenomenal field? There's the qualia answer. Well, every experience gets phenomenal character by these intrinsic monadic features and their combination. And the structuralist answer is every experience gets its phenomenal character by intra-phenomenal structural features. And these are, the web of relations, qualia spaces. We hear of category theory, all these kind of things. So in mathematics, we can be kind of, I think, promiscuous and allow everything that works. But as long as these are just to a degree, these kind of structural features. And these two stand in opposition. And you can think about it if you're looking at your visual field, right? There are two ways to describe this. The qualia theorists can say, yes, the structure of this, the distribution, that's a structural feature. So that I have no problem to account for. But then what gives it this kind of feeling of redness at this point, that's just this intrinsic property, right? And all of these kind of different things get these kind of intrinsic properties associated with certain locations, and you cannot capture those. The structuralist answer would be, no, you get this kind of thing that's, the redness of this is determined by its relation to all other types of experience that you're not having at this point, right? So this is what determines this type of relation. So it's relations all the way down. That's pretty much the idea. Now, we do this not only with vision, but also colors, sound, taste. You do have this in Husserlian phenomenology when it comes to the specific type of structure of time. But you also have it in dimensional kinds of consciousness more generally. The interesting thing how the structuralist answer tries to capture the problem of inverted spectra is a very interesting contingent feature, right? So if you look at the progression of different types of color spaces over time, they do get more complex. The first ones are just one-dimensional, it's just a line. The others, then we have a long, long time where we have these kind of two-dimensional spaces. But, after a certain while, at least in the 1900s, when people are doing really kind of psychophysical works, these spaces become interestingly 3D and interestingly asymmetric. And this asymmetry that you have here in this kind of C-lip space is an interesting feature that might, some people think, give us a way to get out of the kind of inverted spectrum idea. So if we're going from symmetrical to asymmetrical representation of color spaces, some structuralists argue that there cannot be inverted spectra. For example, Robert and Calderon and Lira recently, because our color spaces are asymmetric. And so you cannot rotate them or kind of transfer them to some interesting degree and still match on itself. And so if there were inverted spectra, if we would shift these kind of color spaces, it would be noticeable because the other person would then have experience where the other person would not have experience. And that's clearly something that you can communicate. That is the hope. So the idea would be that if these are so highly asymmetrical, then you could not have these types of inversions and therefore inversions without them being noticeable. And because we do not notice these, there are no inverted spectra. That's roughly the argument. Now, there are still some kind of other things that you can do, which are problematic. And that, for example, would be qualia compression. So you have the normal color space. What you could do would, just crunch it down, keep all the kind of asymmetries and, alignments fine, and then just position it in, let's say, now's color space, right? So now it sees all the colors, but I see like all the different types of relations. I just see thousands shades of pink, right? So while you have the whole kind of range, I only see all the pinks, right? But I see more pinks than now because I've got like much finer grain. They're just associated with this kind of different thing. That's the problem of qualia compression. And it's a new version of this kind of inverted spectrum argument, and it shows that there's something that matters, namely phenomenal distance. So the distances play a role in order to block these kind of both spectra, getting the right kind of asymmetrical kind of spaces, but also avoiding this kind of compression problem. So what is the problem of phenomenal distance? Let me start with an example that I've gotten from Rolf Kühni. This is a very kind of, you can try this out. It's always a risky trying this with the projector, but we can. So you've got this kind of nice shade of yellow. And people are asked to judge what type of other colors might be equidistant, right? So they're being presented, these kind of two colors, and they're judged to be equidistant. They're not just noticeable differences, they are just equidistant sometimes. So then you can say, okay, what's the next step, right? What would be the next equidistant color if we go into one direction? And so, you know, they choose this, and you go way up, and you end up at white. The same, right? So this is equidistant. So what would be the next color that would be equidistant? And you go there, okay, fine. And then you go all the way to black. So it's 7 steps to black. 1, 2, 3, 4, 5. No, 5 steps to black. And 7 steps to white. But somehow this, the step to black, looks like we're making a larger distance than the white one, right? It's like this is very close by. And that seems to be weird, right? So the weirdness comes that the felt equidistance seems to be like an indicator for phenomenal distance. And if phenomenal distance are additive, which you would think they should be, then the distance between yellow and white should be the same as the distance between yellow and black. But that does not seem to be the case. The distance between yellow and white seems to be smaller than the distance between yellow and black. So this is something that we can find all over the place. This is not the only place where we can argue that somehow we get these kind of complications and confusions of measuring out phenomenal distances. Other methods of judgment come up with different types of color solids so that you cannot quite match one to the other. People who are working with this are crudely aware of that. In odor, you do have these kind of things that even the same stimulus can be labeled, can be judged differently, and therefore, like, depending on how you find your dimension odor space, being further apart, even though it's one and the same stimulus. For example, butyric acid, if you label it Parmesan, people will think, oh yeah, that's a cheesy flavor, right? If you label it vomit, it would not necessarily think it's a cheesy flavor. Or I should say odor. And you can find this also in temperature judgments, right? So the previous experience, whether you had your hand in cold or warm water, you know, depends on how far away you judge certain types of temperatures, right? So apparently, and I think that these arguments, these examples abound. So apparently humans are intra and intersubjectively inconsistent in judging the distances between experiences. We're not great at that, it seems. Now, let me provide you a few interpretations of what this means and what this means generally for the mathematics of or structures of consciousness. I'm going to go through these kind of 5 different types of interpretations that you could give. So this again is the problem. The first would be, you could say, well, actually, there are no metrics in phenomenality, right? It's all topology. It's only neighborhood relation, right? And that's all we capture, right? And then we can like shift these, pull these apart, and you know, it's just like, you know, this is the next neighbor. It doesn't mean that they're weirdly far apart. We do have this kind of weird thing that we think that there might be a metric, but that's, you know, we just have to provide in theory why we're having this kind of weird thought. So the problem is that if we're going this route, then we lose this kind of appeal towards asymmetries because, and you know, topologies of the same kind, they do look similar, but you know, they all have the same topology. So there are then no inherent symmetries, and therefore inverted spectra are possible again, right? Because you could just twist things and bring them again right on top of each other. There is a way out if you maybe allow for certain type of hues to be unique, right? So if these kind of unique hues have to match, then the neighborhood relations might match, right? But it would introduce certain things to be privileged, not by structure, but by being unique. So it would limit. Another way you could go, and I think that would be a very normal way to go instead of like full-blown topology at the start, would be saying, you know, there's just these measurement errors. We're just very bad at this, right? So subjects make all these kind of measurement errors and they just compound, right? So if you have a bad measurement stick, like this one from the 12th dynasty, you know, you can still do a lot. You can build, you know, damn pyramids. I mean, that's great, right? It's just you might not be perfect, right? You don't expect like very fine-grained measurements with that. Measurement errors are all over the place, right? You find them everywhere in construction. So why not in constructing qualia spaces, right? I do think that there's something to this. The question is, how far do we want to go with that, right? So it is then, because it might be unclear how far down this goes, right? So are we bad under all circumstances, only under certain circumstances? Can we control for these circumstances? Would be good to know to get an idea of how far off we are. So if so, we should only think that we can only approximate, for example, the shape of a qualia space like color. And then in that range, well, shifted spectra might still be possible, right? If we're a little bit off between you and I might still shift it a little bit around. That might be an issue. Might not be a general argument to say that these are impossible, which is, I think, all right, maybe. Another option I think would be interesting would be measurement dependence, which is something that other than a measurement error, right? So here you would say, you know, it depends on how I measure in order to find out what this kind of shape is. One way would be scale dependence, right? I measure a distance in inches and I measure a distance in centimeters and I just get different results. But I do measure the same distance, right? It's just in different scales, just with temperature. However, I think a more interesting one would not be a scale dependency, but a real measurement dependency as we have it, for example, in quantum physics. And you know that quantum stuff is part of the title here, so I think it makes sense. So in that way, you could say that there is a color space. There are many probably like overlapping structures. And by going with one rather than another of accessing it, I'm actually going for this, right? So there would be a multiplicity of structures, all dependent on the specific way that I'm accessing. But then we have to argue, you know, how we can ensure that we actually measuring shape of consciousness per se. We could not go via different methods to measure the same, right? Because they would all be measurement dependent. And it seems like we're really overblowing the structure of consciousness and saying that there are these multitudes, right? That might not be very economic. And we should give our good argument why we think that we need these kind of different types of structures that, you know, are just there and just being shaped when I'm accessing. So in the absence of this argument, I think that inverted structure are not ruled out because it depends on how you measure it, whether you get it or you don't get it. Now, another thing coming from philosophy of physics would be conventionalism. So there was always this kind of big question in philosophy of physics: what is the nature of space, right? What is the inherent geometry of space? And Poincaré pointed out that actually there is no way to find that out. We cannot differentiate between whether we take a measuring stick and we can lay it on top of each other and we measure space till the infinity, or whether by moving this measurement stick, it halves, right? And always halves, and always halves. Both of these would give us an idea of an infinite space. But we cannot know what our measurement stick is doing when we're carrying it around the universe. So he said, this is mathematically, these can be made congruent with all the data. And so it's a convention, not a data, that we go with this way of modeling rather than another. That could be a way out. So those could be an option, right? We're just saying, like, just by convention, we always pick Seelow space. That's it. Everything else just has to go into that thing, right? All kind of quality space have to be Euclidean. That's what we want, right? All the problems be done. Then, however, one can claim that we're measuring the shape of consciousness itself, right? Because we would just go with a convention. So we're pretty much giving up realism to a degree about the structure of consciousness. And I think that's a high price to pay. It also breaks one of the reasons to distinguish between phenomena and noumena, right? The thing in itself versus how it appears to us. And we heard there are different ways in which things can seem today, if you understand. So I don't think that this is a very, very appealing option. I just want to put it on the table. Now, the option that I would prefer is something that I would think is a hyperstructure at the limit, right? So measures only capture aspects of the real, highly rich structured experience, right? So any kind of color space that we get is just terribly, terribly simplified. The real color space will be massively overblown, probably 4, 5, 6-dimensional, and we don't quite really know what kind of topology this kind of solid would then have. Anyway, that's the way you could go, and no method exhausts it exclusively. So therefore, we're only limited, right, in assessing it empirically. It's like a shadow of the real thing, right? And I do love shadow art, where, you know, like the real thing, the shadow gives you some kind of view of it, but the real thing is much more complicated, much more structure in it, right? And you just look at it from different angles, and all these kind of give you the structures. The good thing is the hyperstructure inherits these asymmetries, right? And so you can keep these kind of asymmetries going. It prevents thereby inverted spectra. It might also prevent kind of certain type of compression cases, because you know there might be holes in these kind of solids that you then cannot directly map onto. So I do think that we get this, but at the cost of just saying measurement is incomplete. Depending on your, you know, character as an empiricist, I would think that might be something that I can live with. But I do think that this gives an interesting type of metaphysics for the background. So thank you very much. I'm looking forward to the discussion. Thank you for your attention.
Discussion. Thank you. That was a superb talk. Super interesting. About the unequal distance being yellow, white, yellow, black.
Right.
So that fluctuation could be resolved if you go to a flat space. So if space is curved, then it could be possible for distances to be unequal. It's like these infinitesimal equal distances.
I have actually no skin in that game. I do think that it's always interesting to try out different types of mathematical structures. I do think that the interesting question that's in the background is, how do we argue which one should we prefer, right? So should we say, oh, this needs a different mathematics in the background? Or we could say, oh, this actually means that we're just really bad at measuring distances, right? So I do think that's the question we have to always ask in the background. Do we pay with epistemological coin or with ontological coin, right? So I do get the feeling that that might be, to me, maybe a little bit much. That's an example where I would say we're probably just bad at doing this. But, you know, maybe if we go into this kind of structure and we get some kind of interesting other predictions that we could empirically test, if these turn out to be empirically testable things and not like the Poincaré thing, right, where we say they are actually empirically equivalent, then I would be, you know, I think that could be an interesting research program. Thanks.
If you interpreted some metric distance as some kind of, for example, I like the example of the transportation. You enter the distance between two stations, pick the least time between them. Such that you go to Mishima station, which is a very one Shinkansen station, but it does not so big station, which does not, for example, the Nozomi Super Express is not arrived at Mishima station. But in such
example of my own heart,
this station, it's a local kind of least time is equal, like Tokyo to Shinagawa, Shinagawa to Yokohama or something like that. But Shin Osaka Tokyo is maybe very short to London. To go to Shima. So it is part of the space like thing, and also the high diagonal thing, because you can embed this kind of graph
Hmm.
in the graph into the very high dimensional space, but not in two-dimensional space.
Mm.
So I think the trying the mathematical structure is not just how to say just a ridiculous game, but it is how to say important to
Mm.
plan
Mhm.
what the argument is.
Mhm.
So I think, how do you think this kind of
I never wanted to say that there's any kind of ridiculous thing about this. I like this idea of like trying out different structures and thinking that the structure of experience might be much, much more complicated than we can. It comes with its own costs, right? Because if it's really highly complicated, we probably can like barely get it. It might be something that is much less distributed in the universe than we thought, maybe.
because why I use public transformation example, that is why this is because this is a very good example of category. Category, which is a station is out, and
Mhm.
path between station is out. So you can think of some good mathematical structure over this very fundamental thing which we get.
Mm. If I may say so, so there's an interesting way in which also, I'm not a great mathematician. I'm barely a mathematician. I'm not actually at all a mathematician. So but the one thing that I find interesting is, right, you have these different type of foundational projects in mathematics that are supposed to be, give you similar things, right? Set theory is one, which might be wrong. Category theory might be a different one that gets interesting things. Even the kind of topology ones, right? Homotopy type theory might be some things that, but I'm wondering how much do we really have to throw this on there? How much structure is actually needed? Right? That's I think the interesting thing. And where do we really maybe overblow or like impose structure on it because it's mathematically convenient, right? So I do think also that this kind of payback between being empirically adequate and doing things because of a convention, I think that's also an interesting, like this kind of tension to take care of. Yes, thank you so much. Yeah.
And I think the idea also, things like here is actually reflected also in our similarity measurement. I think we actually give a brief talk during this symposium in SSC, but when we try to match the structure of the human similarity matrix, RGB space, or CIE lab space, which is a very low level, it's very hypothetical space, it doesn't align at all. It's just at all. However, when we align it with the ChatGPT-4, aligned well, but it didn't align ChatGPT-3. And the difference between the 3 and 4 is that the input of the visual image plus language. That's a GPT-4. GPT-3 only has a language. So one hypothesis is that the language alone, categorical structure, that doesn't reflect our similarity or appearance, seeming similarity, but something, we don't know exactly much, but combination of the linguistic structure plus this, appearance itself. Probably explain this. Your idea of the station maybe corresponding to the level, but difference maybe more to do with this kind of changing thing, right? Then there may be some kind of push between the actual single difference.
Maybe I can also add something to this. So I think that one of the things that are terrible or maybe misleading is that in the literature we very often speaking of color solids, right? And there are these closed forms. But actually, if you look at this, it's this kind of weird distribution, right? So it's closer, it's not a marble, less out there. It's more a sieve, right? And if it's a sieve, then it's kind of harder to compress and maybe do these kind of also Qualia compressions. So I do think also like there are these kind of misleading ways of making things solids that maybe are not, and that might have interesting kind of associations. So just to add on this, I do agree with that direction that you're going.
And I wonder if possibility was an additional one to the one that you discussed, or whether it actually fell within one ones you were discussing. So can you go back to the nice picture with the dogs on it? Yeah. So I mean, one thought is that what's represented there is just a subset of total colors.
Hmm.
And of course, we are creatures who conform to this particular model. I think one of the things they often say is there isn't a yellow to black. For someone who's color inverted with respect to me, you know, they would say those words too, obviously, but what they would really mean is that there isn't a greenish black. But they would think there isn't a greenish black because they've never experienced a greenish black. But maybe there's this, so maybe the fact that there are these asymmetries doesn't all reflect color inversion. It just shows us again that we ourselves are very limited by the particular set of experiences.
I like that a lot. So yeah, we talked about this shortly before. Yeah, I find that very interesting to think that, you know, there's the space of all possible experiences. And we're just, you know, meandering in our small little neighborhood of it, right? This kind of small subset where we know everything. We think that's the world, right? And then we meet other people that come from, you know, other areas in the color space and realize, oh my God, there's so much more there. I think that's great. It gives a little bit of a different spin. So I think it switches a little bit the scale of this, right? Because I was mainly talking about an intrapersonal space. And we're now talking about spaces that include the experiences of every person and every conscious individual. So that would clearly build up towards thinking of consciousness as this kind of hyperstructure, right? It's extreme in its dimensionalities. We might not even capture all the dimensionalities that consciousness might have. But it is a different, like, it seems like this is a little bit of a different topic than I tried to capture, but I'm there with you. Yeah.
Considering someone who's color inverted to me,
Right.
And how you would have to add in a limited range of colors to this to capture both of our experiences. So you would have to add in what I would think of as yellowish blacks into this model.
Yeah.
To do that, then we can get there. And then we just say I experience a subset of those colors in there.
Yeah. So I think that's a good way. I also think that we should add different paths, right? So it's not just like I'm in this area and I'm in that area. It's also that I only went from red to green this way, right? And then all of a sudden I'm being shown, you know, there's this shortcut. And I think that makes a lot of sense. I also want to say that this is an interesting picture because it also allows certain types of shifts, right? The 0 point for this kind of hugely dimensional space would not necessarily need to be fixed, right? For us, it might be this kind of neutral gray where we're saying the deviations we measure from, but it could also be that the 0 point is being shifted for a different individual, right? That raises also interesting kind of translational question. I think there's a lot there that to reconsider. Yeah, I like the proposal. To me, it does go a little bit to the hyperstructure thing, but I do think that that's a great way to think about. Thank you for the possibility.
The last question, very short.
Very interesting. You want to talk about that the coupling between the quantity, motion quantity, and motion measurement. It's very similar to the philosophy of the Niels Bohr about the complementarity.
Mhm.
He claimed that the quantity, for example, the quantity position, the moment, measurable, he especially said that quantity position is defined only when the context in which the system is coupled with the measuring apparatus with the position. Momentum quantity is also the defined only when the system is coupled with the measuring apparatus of the momentum. So his philosophy is very nice to describe the definition of quantity and also the value of observable. The usual Copenhagen interpretation is not successful about defining the value of the observable. So I think that each kind of the decoupling between the quantity and measurement is necessary for the study of the consciousness.
Mm.
The mathematical approach from the category theory will establish some pretty nice mathematical tool which construct the category algebra. Algebra is just the algebraic structure of the all quantities, but this quantity and measurement is not so directly connected in this part of the classical method. In this case, we start with category of the sum operations, and then we construct the observable, means that the algebra quantity. And over this algebra, you can define the state as a linear function describe expectation value of the measure. And then you construct the instrument which describes the operation of the measurement, which is determined by the stuffing instruction. So in that way, there is some very nice route to develop the decoupling the quantity.
Mhm. Yeah. Can I just shortly comment? Very short. Yes, so I generally like, it seems as if there's this kind of wave that's then happening, right? We're trying to treat phenomenal spaces as we did, you know, the universe. We tried to measure the universe, now we're trying to measure the egoverse, right? In the next expansion, there's lots of riddles to be had there and, you know, wonders to be found. However, I also think that I think it's great to have these kind of inspirations from the way that philosophy of physics and physicists try to capture, you know, how to measure, not things that are not directly given to observation. But that's also, I think, where the interesting disanalogy comes, right? I mean, the whole idea of consciousness was supposed to be that there I don't have, you know, how it appears is how it is, right? And so I do think that certain ways in which we transpose kind of physicist thinking to consciousness might not fully work. And we have, I think, more degrees of freedom in physics than we might have in consciousness. We might have to introduce this kind of access versus phenomenal consciousness thing in order to capture this kind of thing again. It's a very interesting thing that's happening, and thank you for your comment.